So here's an example of a non-piecewise function where we want to determine where it's continuous. First, we want to determine if it's continuous at a equals 3, and then at a equals negative 3. Well, for continuity, at a equals 3, we need to evaluate the limit from the left, the limit from the right, and the value of the function. Well, first, I'm going to do the limit as x goes to 3 from the left of x plus 3 over x squared minus 9. I start out by plugging in 3 for x and seeing what I get. I'm going to get 3 plus 3, which is 6 on the top, 3 squared is 9, minus 9 is 0 on the bottom. Aha! We have a number divided by 0. Whenever we have a number divided by 0, that tells you that the limit is infinite. Again, a limit is infinite means that the limit does not exist. Infinite limits are a special way in which limits fail to exist. Since the limit does not exist, it is going to be discontinuous. It is not going to be continuous. Anytime the limit fails to exist, it's automatically going to be discontinuous no matter what happens to the value of the function. Now if we want to talk about it at a equals negative 3, well, if we want to do the limit as x goes to negative 3 from the left, well, if we do that, we get x plus 3 over x squared minus 9. We plug in negative 3 for x. We get 0 on the top and 0 on the bottom. In this situation, we have to factor and cancel. So we get the limit as x goes to negative 3 from the left. We get an x plus 3. On the bottom, when we factor, we get an x plus 3 times x minus 3. The x plus 3's cancel. We plug in negative 3 again. We get 1 over negative 6. So the limit from the left exists and equals 1 over negative 6. Let's try the value of the function. Let's see what f of negative 3 is. When we plug in negative 3 for x, we get 0 on the top and 0 on the bottom. 0 over 0 is undefined. So, since f of negative 3 is undefined, since the function has no value at negative 3, this thing does not exist, so it is discontinuous. Again, just to mention, if you get 0 over 0 when evaluating a limit, we're allowed to do factor and cancel. If we get 0 over 0 when evaluating a function, we're not allowed to do factor and cancel. 0 over 0 is undefined for the value of a function, but for a limit we can do more work to make it work.